Yes, yes, I
Okay,
can see it.
yes.
I should just start, right?
Yes.
Okay. The aim of a credit card validation is the process to check if a credit card is valid for online purchases or not. It gives merchants a way to verify the validity of a card number before accepting the customer's payment. The calculation is to verify a credit card number. It's also known as loan algorithm. And it also helps to protect against internet fraudsters who want to use fake card numbers to purchase goods or services online without anyone knowing.
All right, thank you. So that's the aim of the project. But before we go into the project, we need to understand what the loan algorithm is all about. So would Chidera please explain the loan algorithm for us?
Okay. Can you hear me?
Yes, you can. Yes, you can.
Okay. So the loan algorithm, also known as modulus 10 algorithm, is a formula that is used to determine whether the identification number provided by a user is accurate. The formula is widely used in validating credit card numbers as well as other number sequences such as SSN. Today, the loan algorithm is an essential component in the electronic payment system and is used by all credit cards. So, one thing I would like to add to this is, when you are about to purchase something, like if if they only accept Visa or Mastercard, and you're about to put a VEF card, I think the loan algorithm is the stuff that's going to help determine if the card you're putting is Visa or Mastercard. So you can, if you notice that when you just put like the first phone number, already it knows that it's not Visa or Master. It should just tell you that this is not this thing, that you can't add it. So I think it's the loan algorithm that helps to do that. Yeah.
Yeah, thank you. That is the explanation for the loan algorithm. And if you look at our slide, there's a way to understand how the loan algorithm actually works. But we are moving on to the objectives of the project, and that will be taken by Dozie.
Okay, so a credit card is contain like several items, which is called the hologram. So it's verified by combination of the metadata, which is the issuing company. So that's really what I actually know for that. Can you hear me?
Yes, yes, thank you. Moving on to the scope of the project. That is Jerry.
All right. So one major limitation is that the algorithm can only detect single-digit errors, like nothing more than that, just only single-digit errors, including transpositions of adjacent numbers. However, this isn't the case for transpositions of the following sequence: first valid character, the last valid character to the last valid character, and first valid character, or vice versa. What this means is, in the case of a 0 to 9 digit set, transcompositions of the 09 to 90 or vice versa won't be detected by the known algorithm. By that, as it may, the algorithm enjoys wide acceptance, particularly in finance, as it speeds up electronic payments processes and also makes them relatively easy.
Thank you very much for the scope. This just proves how accurate and used the loan algorithm is. Now to the justification of the loan algorithm.
Um, this is justification of the problem. This is basically we are trying to see the importance of the credit card validation. It is important to keep in mind that whenever fraudulent cards are used, the merchant loses. The customer of a stolen card is not hooked, and the credit card companies are generally not affected. However, the merchant generally stays away from the products or service provided, as well as the resources necessary to discover the fraud and fights against the credit card company. And if too many fraudulent transactions occur, you may incur higher processing fees, expensive chargebacks, or even losing your merchant account and your ability to do business. But you can mitigate these risks with the help of a little automation, and we can help you simply use our online card validator tool and how to help you to combat fraud and maximize the sales of your credit cards.
Thank you very much. Those are the justifications of our software, and it is a credible software that you can use to validate your credit cards. But what are the limitations of our software? So, first of all, our software doesn't work for Verif cards. The FCMB Naira Verif cards is a Naira denominated debit card, which can only be used for ATM cash withdrawals, bill payments, and purchases for goods and services online via POS terminals only in Nigeria. Cards like the Visa card, the MasterCard, America Express, and Discover cards are used in over 200 different countries. That is why that's why the credit card validator app only works for those cards and not Verif cards. Another limitation is the limitation of the loan algorithm that was mentioned earlier. So we've talked about the project, but does it actually work? So we are going to demonstrate the project now. So it says card type is Visa card and card number is valid. So we were able to show that the our projects can verify and validate a credit card. But how does this program work? And I'll be the one explaining the code. So if you look into the code, it starts with include iOS stream, array, CMath, and strings. These are all C++ libraries that we indicate at the beginning of the code. Then we have the card breakup function. Now what this function does is it takes the card number and the length of the card as arguments. It creates an array of integers called card bits, and it checks to see if the length of the card number is greater than 13. Next, we have the validate card function. It's a Boolean function which returns either true or false. So the first thing it does is it takes the card number as a string and converting it to an array of integers. It's reversing the array, multiplying every other number by 2, and adding the digits of the numbers that were multiplied by 2. Then we have the card type function. It creates a function called card types that takes in two arguments, card length and card bits. It creates a variable called C type, setting it to an empty string, and it returns the value of C type. So that is basically how our code runs. I want to say thank you for that. Is all for the presentation. Yeah. Sure.
Okay, now.
Yeah, so thank you guys. That was all.